Hey everybody, this is John here with GPMech, where we help you go faster, faster. Today I want to give you a brief overview of one of our new software tools, which is a gearing calculator. Now, if you're into racing, you've probably seen systems similar to this before. So I'm going to start from the result and I'm going to work our way back to how we get there and tell you a little bit about what makes our system unique. So the result is here, is this graph. This graph shows you acceleration in G's along the y-axis and your speed along the x-axis. Down here, if you click, you can see that for a given vehicle, you get each gear your theoretical top speed. Currently, these are in kilometers per hour, but you can change the units if you want to miles per hour with just a click of a button, but we'll keep it in kilometers per hour for now. So what are we getting? We're getting acceleration at a given speed for each gear. So lowest speed and highest torque is obviously going to be first gear. Our vehicle in this case is called Ultra Lion. It picks names at a little bit random. So you're going to see that we peak out here in first gear about 1.3 Gs when we're going about 100 kilometers per hour. And then you can see as we go down, the acceleration goes all the way until we get to 0 Gs capable at about 300 kilometers per hour, or the top speed of this vehicle. So if we click in here, we can see that our theoretical top speed in sixth gear, and that's based on our gearing, should be 320 kilometers per hour, but based on our power, we are aero limited to 300 kilometers per hour. And that's one of the first big benefits of this tool over other typically free tools, is that you can actually see what your top speed is based on aero limitations and not just based on gearing. And the acceleration values that you get here take into account aero limitations as well. The other graph that we give as output is the actual torque that's available at your rear wheel. And so as you change gearing, your torque will change as well. And your acceleration can change based on a number of things. So up here we have our name. Let's call this Yamaha R1, because that's roughly what this vehicle is based off of. So we change the name to Yamaha R1. Then you'll see that the name changes down here. And we have our inputs here. So this system's designed to be as easy to use as possible. I don't want you to have to be an engineer in order to use the system. So you have a number of different inputs that define the vehicle. We start with the chassis and aerodynamics, and you can either put the tire diameter in directly, or you can put in a size. So if this is a Yamaha R1, chances are we're using a 265/17 at the racetrack, and that's going to calculate out to roughly 692 millimeters. This is just a guess. Your actual tire may vary, so if you're using one manufacturer or another, check with their information. They might give you an actual direct radius, but this just auto-calculates based on the size. It's a nice, easy way to check it first. The next step is the rider and vehicle information itself. So vehicle mass, I think the R1 is about 195 kilos, and my weight is about 87 kilos. So we can put that in there. And then this is the part that makes things a little bit interesting. This drag area. This is essentially the number that defines how much wind resistance your bike has. Now, you might have heard of drag coefficients before. Drag area just takes that drag coefficient and multiplies it by the total frontal area. You're probably not going to know what this is for your bike because you probably don't have a wind tunnel. So a good guess for modern sport bikes for a rider in a tuck is about 0.35. So that's a good place to leave it unless you have better information. And there are ways to calibrate this from your bike and your setup directly. We'll get to that probably in a few weeks from some other videos. If you guys want to hear about this and you want to learn how to calibrate your drag area, then let me know in the comments below. Then what we have to define is our transmission. So typically this area, the primary drive and transmission, you only have to change once for a particular vehicle. So you'll input the primary reduction. This is from your crankshaft directly into your clutch basket. So in the case of this vehicle, it's 67/41 for a 1.63 ratio. And then we go through all the gear ratios here. Now, if you want to change things or alter things, say you got a different bike, you can go in here. You can update these teeth directly and it'll calculate for you. Or you can enter a gear ratio directly. We'll leave these where they're at. You can also add gears or remove gears with the X. So if you only have a 5-speed bike, you can remove the 6th gear, or if you have more gears somehow, then you can add those in there too. This minimizes down because we're normally not going to have to play with that, and leaves us with what is our typical important part. So this is our final drive. So we have a rear sprocket and a front sprocket, and we can change those. Currently this is showing a 16/41, but maybe we're going to be running a 16/44 or something like that. You can update that, and again, you see this updates automatically. We'll leave it at a 1641 for now. And then if you want to see what the total gear ratio is, so that's your primary drive times each gear ratio times your final drive, you can get that information here. And we have an area for our dyno information. So you can either upload a file here, and I'll do another video showing exactly how this process works, or you can use the example information that's given. So this is going to give you both torque in the dotted line and power in the solid line. And in this case, it's kilowatts and newton meters. And you can see they cross over about 9550 or whatever that number is where they cross over. You can edit points here, but the best thing to do is you're probably going to have a CSV file from your dyno output. You can take that for your particular bike and upload it directly here. Again, that's the cool thing about this system is it allows you to customize things to your actual vehicle and not just to generic vehicles. But it still has some example data if you just want to play around and get a feel for things. So we've got our bike, we've got our acceleration. Now this is where another one of the areas where I think the system really shines is we can just copy the file. So now we have Yamaha R1 copy, and I'm going to change this to 4423er, and I'll change this to 4123er. You can change the color if you want something else, but the green and the blue are pretty good contrasting colors. So now we have a direct copy, and you can see right now it looks like there's just a green line, and that's because these bikes are identical. We haven't actually changed to 41 and 44 teeth yet. It's just a label. So we'll change to 44 teeth, and we'll see here what the effect that has on our available rear wheel torque. So obviously as you go to a larger rear sprocket, you're going to have more torque available at the wheel. But if you look over here, again, we've got more acceleration capable at the lower speeds, but then around the top end, our speed may drop off. And if we look at the top speed in each gear, both vehicles are still geared for, this top speed went up because we went to a bigger tire. So we're going to have a theoretical top speed of almost 350 kilometers an hour for the original 41 tooth and 325 kilometers an hour for the 44 tooth. Now for both these bikes, they're aero limited to 300 because your top speed is just based on your CDA, your aero drag, and your total available power. And since these vehicles have the same engine, we're going to have the same top speed. So why don't we make a slightly more drastic change? We will go to 1545. So we'll go 45 tooth there, and we'll see one more. We'll go down one more tooth in the front. So we probably wouldn't do a 14 tooth on an R1, but for the sake of example, now we can see what we've got with this 45 tooth rear. It's got a 14 tooth front, and our top speed in that final gear is 278 kilometers an hour, which is actually below our top speed available. And this is kind of where that trade-off between your low speed acceleration and your top speed comes in. So if you're gearing for a track that you know you're never going to get above, call it 275 kilometers an hour, this is a good gearing. You wouldn't want to have all this extra gearing, all this extra potential top speed that you're never going to reach at a given track. You want to maximize the acceleration you have available. So this tool is great if you know roughly what your top speed is going to be and you want to see what gearing would make sense for you. It's a great way to try out some sprockets before you go ahead and purchase them, and it's also a great way to just kind of learn a little bit more about your bike and about the way that it functions. And you can see what an acceleration jump we have. So we go from just over 1.1 Gs, it looks like, peak in first gear for the previous gearing, all the way up to 1.4 Gs with the new gearing. And now, granted, at 1.4 Gs, you're wheeling the bike anyways, but that's part of the fun. So I hope you learned something today. If you want to try this tool out for yourself, head over to gpmech.com/gearing. Give it a try. If you got something from this video, then leave a comment down below. If there's something else you want to see from this tool, it's still under active development. Again, leave a comment down below, and we'll try and get this tool to be as best as it can be.